Alright, this is 5.4. Solving systems of equations using any method. A system of linear equations can have one solution, no solution, or infinitely many solutions. So one solution is pretty straightforward. That's where if I have a graph, just a really rough sketch, and I have a line going this way, and another colored one, maybe going this way. Where these meet is a solution, and this is one solution. Alternatively, if I had a graph, and this is not going to be perfect, but I'll just say, okay, I got these 3 points, and so it's like down 1 over 1, down 1 over 1. And then I have, let's do green, and it has the same rate, and they're parallel, they would have no solutions. Alternatively, if they wind up being the same line, let's just change it up a little bit. I'll go like this. So there's that green, but then the pink is also those same points. There's an infinite number, so infinite. The many solutions. So that's important to know in this, simply because for both of these two on let's just for both of these, the way that we can kind of tell is they need to have the same slope. Same slope. And the only difference is this one has different intercept. And this one has the same intercept. That's the difference between those two. Okay, so we have a couple questions that we're going to be answering as we kind of go along here today. The first one is labeled as number 1. So number 1 says, if I have y equals 3x minus 7 and y equals 3x plus 4. Now, you might right off the bat see and be able to tell what that is. And if you do, awesome, good for you. However, we're still going to go through this just in case you don't, and just so you can see what happens whenever you come across something like this and what it looks like. So, in this method, or in this one, I'm going to use substitution. And the only reason I'm using substitution is I already have the variable defined, where I have y equals blah, blah, blah. Admittedly, that's for both of them, and that's totally fine as well. So what I'm going to do is I'm going to say, okay, I got 3x plus 4 equals 3x minus 7. And maybe I'll just like kind of circle this. Do that. That way people that are looking at this see what we did. And so we can go from this and we can say, okay, if I have 3x plus 4, that equals 3x plus 7, or minus 7. I want to, let's see, I'm going to subtract 3x's from both sides, just so I can get the x by itself. And I get 4 equals negative 7. Oops, negative 7. Is that true? Is that a true statement? Does 4 equal negative 7? No. Does it ever? It never equals. So, what we have here is no solution. And let's say, okay, you're still not quite convinced of this, and you're like, oh, but we need to subtract 4 from both sides. Okay, so we get 0 equals negative 11. Well, that's still not a true statement. So we have no solution. These wind up being parallel to each other. They're parallel. Okay. Let's try the next one. Number 2. Y equals 5x minus 1, and y equals negative 5x plus 5. Again, I'm probably going to use substitution on this just simply because we have these things that are already isolated. So I'm going to take this, and it's going to go up for this. So I get negative 5x plus 5 equals 5x minus 1. Going to get the x's by themselves. Let's just subtract 5x's from both sides. And we're going to subtract 5 from both sides. So I get negative 10x equals negative 6. Divide by negative 10. Divide by negative 10. X equals 3 over 5. Now we need to, so we have the x for this, we have 3 over 5. We need to get the y. So y equals 5 times 3 over 5 minus 1. This is the top one. The 5's cancel out. So you get y equals 3 minus 1. Y equals 2. We can always go in and check. So 2 equals 5, 3 over 5 minus 1. We just did this. These cancel out, so we get 3 minus 1. 2 equals 2. Yeah, that one was fine. Now we try the other one, where we have y equals negative 5x plus 5. So we get 2 equals negative 5. 3 over 5 plus 5. The 5's cancel out, but it doesn't get rid of the negative, so I get 2 equals negative 3 plus 5. So 2 equals 2. That checks out. That's your answer for number 2. Number 3. 2x minus 3y equals 10. I get negative 2x plus 3y equals negative 10. I say, okay, which one's going to be eliminated? I see at least the x's are going to be eliminated, so I say, okay, I'm just going to continue on. So 2x plus negative 2x is 0x. Negative 3y plus positive 3y makes 0y. Wait a minute. 10 plus negative 10 equals 0. So 0x and 0y is 0. 0 equals 0. So the question is, does 0 equal 0? Yes. It always equals 0. Always. That's not how you spell always. It's an extra L. Yes. Always true. Which means there's infinitely many. And that's what we're looking for that infinite. Okay. On these next two, definitely try and do them, or next three really, try and do them on your own before following along with me. This one is labeled as number 8. So 4x plus 3y equals 17. And negative 8x minus 6y equals 34. So like I said, try and do these on your own. Go ahead and pause it, and I'll just be continuing on. So whenever I look at this, I want to say, I want to try and eliminate, I don't know, my x's, just see what happens. So eliminate x. So I have 4 and I have -8. I need to make them match up, so I need to multiply this by 2, this by just 1. Multiply this by 2. Multiply this by 1. So I get 8x plus 6y equals 34. And -8x minus 6y equals 34. This makes 0x. This makes 0y. This makes 68. 0 equals 68. Is that a true statement? No. Not true. Is it ever true? No. So there are no solutions. Okay. Let's try another one. Number 9. 3x minus 2y equals 6. -9x plus 6y equals -18. Again, try this with your partner or on your own if you don't have a partner with you. Go ahead and pause it and I'll be continuing on. Alright, so I'm going to ask, what do I want to eliminate? Looking at this, let's go ahead and eliminate the x's. Why? Because I feel like it. So I have 3 and I have -9. I need to multiply this by 3 and this by 1. So I have 9x minus 6y equals 18. -9x plus 6y equals -18. 9 and 9 makes 0 x's. -6 and 6 makes 0 y's. 18 and -18 make 0. 0 equals 0. Is this true? Yes. Is it always true? Always. That tells us there's an infinite number of solutions. Alright. Finally, number 19. You have $15 in savings. Your friend has $25 in savings. You both start saving $5 per week. Write a system of linear equations that represents this situation. Will you ever have the same amount of savings as your friend? So I'm going to write everything out. So U equals $15. Friend equals $25. You save $5 and friend saves $5. So we're going to write a system of equations with this. We're going to say x equals the number of weeks. This isn't told to you specifically in here. However, x is typically represented as time. Y is going to be your total. So if we write this out, so you have $15. Let's just make this the U statement. You start with $15, and you're going to add $5 every week, which is x, and you're going to have some amount. Your friend has $25, and they're going to save $5 a week, and they're going to have some amount depending on the number of weeks. So you could use substitution or elimination in this. For me, I'm going to use elimination because you want to find out when you're going to equal the same amount as him. So when are these two going to equal each other? And so we can plug in this y for this other y. I guess I could show this is going to go right up there. So I'm going to have 15 plus 5x equals, I'll change colors for this, 25 plus 5x. I guess I should technically put this into parentheses. So I get 15 plus 5x equals 25 plus 5x. Let's subtract 15 from both sides. Let's subtract this 5x on the right from both sides. And I get 0 equals 10. This is a not true statement. And it'll never be true. So that means there's no solution. Which means you'll never have the same amount. They will always have $10 more than you. Okay. Alright, that concludes everything that we're doing in this. So make sure you check what your assignment is from your teacher. Have a good one.